Hi, my name is Alan Bachman. I'm the co-founder of RAGmetrics. Suppose you're developing an LLM application. You've built a demo, it looks pretty good, but is it ready for production? Will it handle what your users throw at it, or will it hallucinate and go off topic? Today, in this demo, I'd like to show you how you can start to address these problems in about 5 minutes with no code. Let's get started. So what we're going to do today is we're going to start by connecting RAGmetrics to your service key. Then we'll enter the prompt, we'll create a label data set, and then we'll evaluate your model on that label data. The first step is to link the model to your key. It could be any of the commercial providers or your own custom endpoint or the Hugging Face one. I'll use OpenAI. The next step is to enter the task that you'd like the model to do. In this case, we're going to build a New York City tour guide. We're going to use the ChatGPT 3.5 Turbo model. And we'll give the prompt to the model, you are a New York City tour guide. Next, we need to create a labeled data set to show what the model should do. Let's call that label set New York City Wiki. We can generate this data set from a couple of different sources. First, we can upload it from a spreadsheet. This is what the spreadsheet looks like. The spreadsheet will have 3 columns: the question, the answer, and the gold context. But today, rather than creating it from a spreadsheet, let's create it from some reference documents. Now we can upload those reference documents. They might be PDFs, text, or really anything else. But in this case, we'll actually load the reference documents from New York City's Wikipedia page. So as soon as I hit save and continue, what this is going to do is it's going to read those documents, chunk them, parse them, embed them, and create 10 questions and 10 gold answers for that data set. And next to each gold answer, it'll actually identify where in the document the answer came from, which we call the gold context. So here's an example data set, and we can see the first question is, how has the location of New York City at the mouth of the Hudson River contributed to its growth as a trading post? There are a bunch of quotes from the Wikipedia page. Oops, let's come back to that. And the ground truth answer is the location of New York City at the mouth of the Hudson River has contributed to its growth as a trading port because it provides naturally sheltered harbor and easy access to the Atlantic Ocean. Okay, so we have 10 of these questions, 10 contexts, 10 sets of contexts, and a ground truth. We have our label data. The next step is to see how well our model does on this labeled data. Let's name our evaluation. Let's call it accuracy. And here we're going to take a look at some evaluation criteria. Let's look at the context precision, which is how often does the retrieval model bring in the correct context. Let's look at the gold rank, which is how far up in the prompt does the gold context come in before incorrect context come in. And we'll also look at the answer quality, which will be on a scale of 1 to 3. And we'll use GPT-4 as our judge. Now there's a couple of other criteria that we could use, such as whether it's a valid JSON or even our own Python function, but we're going to skip those for now. Let's run this evaluation. Okay, so now as the evaluation runs, it is generating answers to each of the 10 questions that we created in our label data set, and then it is comparing those answers to the gold answers that were created in the previous step. And it is comparing the same, it is also assessing the context retrieval to make sure, or to check whether the correct contexts were injected into the prompt. Let's give it a couple more seconds for it to finish working. Okay, so we have our evaluation results, and under evaluation details we could see what we named it and all of the information that we accumulated on the previous screens. And our evaluation results show that most of the context is retrieved correctly, and usually the correct context is ranked near the top of the prompt. That's good. We also see that our answer quality is pretty good. It's 2.4 out of 3. And we spent about 10 cents for this evaluation. We evaluated 10 questions. We processed some tokens on the input and the output. We can actually download the details here to see what happened on a question by question level. But suppose that we are not happy with this answer quality. Suppose we actually want to improve it. We can go back to our code and actually improve the code. But the simplest thing that we could do is to change the model. Let's do that now. So we'll go back to the tasks. Here we have our New York City tour guide task, which we defined previously, and here are our results. Let's go ahead and edit that task. And instead of using ChatGPT 3.5, we'll use ChatGPT 4 as the generator model. We'll update the task, and we'll, before we run the evaluation, notice that now that we've updated the task, we have two versions of it, the old one and the new one. We can actually click to see the history of those versions so that it's easy to reproduce an experiment. And we have our evaluation history here. We've only run the evaluation twice. But now we're going to run it again. As we run the evaluation a second time, notice that the generator model is now GPT-4 instead of GPT 3.5. Now, GPT-4 is going to be a little bit slower, but it's going to do the same thing. We're going to have GPT-4 answer the questions and then compare them against the gold answers that we've prepared earlier. Perfect. So now we have our evaluation results, and we can see that the context precision and the gold rank are the same because we're actually using the same model to do the retrieval. But we're using a different model to do the generation. And you'll notice that our answer quality has improved from 2.4 to 2.7 out of 3. It's also a little bit more expensive. Now we can again download the results to see where they're different. But if we go back to our task, we can now see both evaluations from 2.4 to 2.7. Thank you very much.